segment. Let's get to it. Today's Cosmology segment features an article here about ghost particles, otherwise known as neutrinos, the least massive particle known in the universe. And this is an interesting one as it's talking about a tidal event. So the massive radio sources located at the cores of galaxy, commonly referred to as supermassive black holes, we'll just refer to them as massive radio sources, they spit out jets of material. When those jets are oriented directly toward your location, they're known as quasars or blazars. And this particular one is interesting in that it seems to have generated a neutrino as a result of a possible star being consumed by the black hole. So these tidal disruption events are believed to involve a star getting too close to the event horizon, part of it being drawn in and part of it being blasted out, which powers up the toroidal field and perhaps later powers up the poloidal field. And what we're talking about with poloidal and toroidal fields are this. This area right here, which rotates around the massive radio source, that is a poloidal field. And these jets emanate from a poloidal field. So know the difference between a toroid and a poloid, folks. That's my best advice. And perhaps check out this article. Another great artist rendition here of what happens during one of these tidal events. Again, this article is on SciTech Daily. The event known as AT 2019 DSG is the alleged tidal event that we're talking about here. So perhaps have a read. A tidal disruption event coincident with a high-energy neutrino is the paper cited in the article. Again, you can find it on SciTech Daily. I think it's a lead article today, actually. And let's talk about triple quasars. Thanks to our viewer who commented on this. We were talking about double quasars a few days ago. Now we're talking about triple quasars. Here's a phys.org article about it. Extremely rare, a triple quasar. What's so rare about it? Well, what's so rare about it is that this particular galaxy has 3 extremely massive radio sources at its core, and each poloidal field is oriented toward you, which means all 3 of these galactic cores are oriented in the same direction. So you've got 3 of them, all of which have their poloidal fields oriented toward you. So this is believed to be a result of a galactic merger. You can see A, C, and B. Those are all quasars located in galaxy J1519 plus 0627, the triple quasar system. Now this article is all the way from back in 2013, but you can find it just for searching triple quasar. This one is in the phys.org section. A very rare scenario. QQQJ1519 plus 0627 is the galaxy in question. Let's pick a random object real quick. Today's random number is 340. Let's see what it coincides with at the Neil Gorell Swift Bat X-ray Observatory. It's V906 Carinae, some sort of an X-ray source, and you can see it's a very diffuse X-ray source. And it's only recently been monitored here. The historic graph only goes back to earlier this year, so this one's super interesting in that it's quite new on the list. But it's also a very weak X-ray source. As you can see, the levels here are only 0.005, for example. And let's see if we can get a visual of this, and we cannot get a visual of this as there is no link to Sinbad here. So let's move on. There's even more cosmology stuff to cover. Is this even cosmology? Well, what about 3D superconductors, which form into 2D superconductors, which cause pools of electrons to spontaneously form? Why? Because of the intrinsic properties of the superconducting materials. Now, does this apply to space? Some of us think it indeed does. But anyway, it's another SciTech Daily article. It's as if when given the power to superconduct, the 3D electrons choose for themselves to live in a 2D world. Does this have something to do with what's going on with stars? Well, one of the problems, folks, with mainstream heliophysics as well as other alternate theories of how stars behave is where do all those electrons come from? And guess what? If they come from the intrinsic properties of what the stars are made of, condensed matter, then perhaps that is where the electrons come from. It's pretty important as the solution to where all those electrons come from. How the stars behave the way they do is kind of important, and maybe somebody's figured out in a lab how that works. This is a repeated thing here, by the way, as Stanford replicated the results. Puddles of electrons forming into their own 2D structures, as if by their own will. And that's today's Cosmology segment, a regular feature here at the Smash News Network, least busted name in news. And we'll have to say goodbye to Twitch until we return for our meteorology segment.